We're ready to begin assembly on the transmission. There's three items: this Torrington thrust bearing, the number 4 blocker ring, and the pocket bearing. Those three items, we're going to need a little help holding those in place during assembly. So we'll take a small dab of grease and use that to help retain that pocket bearing. Small dab to help retain that blocking ring, and the last little bit there to hold that Torrington thrust bearing in place. And that way those three components will stay where they need to be as we assemble the transmission. As we reassemble the transmission, the first thing we put in place in the case is the counter shaft. Now we install the counter shaft, and the shop manual does not tell us to reinstall the bearings, but it doesn't tell us to leave them out either. We have to leave the bearings out. I've seen several people come in, only makes sense to install the bearing. Well, when you install that bearing, that holds that counter shaft up, and there's not room to get the main shaft back in place. So we've got to leave the counter shaft bearings out. And with our counter shaft in place, we drop our input shaft in, and then work our output shaft in. And then we have to get those two mated together. And now the three main shafts, the input shaft, the counter shaft, and the output shaft are all in place. And now we can begin to reinstall our bearings. That rear counter shaft bearing started. The rear output shaft bearing started. And the front counter shaft bearing. And the input shaft bearing. So now all the bearings are started into place. We'll install the rear bearing retainer, and once the rear bearing retainer is installed, then we'll be prepared to measure the in-play. Gone ahead and installed the rear bearing retainer, snugged these bolts down. There are no shims or no selective components behind the rear bearing retainer. We've got to get that installed. Next, I'm going to stand the transmission up on end. The weight of the main shaft and the input shaft will be down against that bearing retainer, and that'll allow us to make the measurements for the in-play, which is set on the front for both the counter shaft and the main shaft. Got the transmission supported vertically here, and I'm having a bit of a problem. I can't get this front bearing to seat down nearly as far as what it needs to go. And I've traced the problem down to a build problem lower in the gear train. I have to get the transmission back up on top of the bench in order to show you that problem. One of the reasons we do in-play checks is to verify that the whole transmission has been built correctly. I've heard people say, oh, I just did this or just did that. I don't need to worry about my in-play checks. I've obviously had this transmission completely apart, but put it back together using the same components. But I found my second gear is loose on my main shaft. And what that tells me is when I built the 1-2 assembly yesterday at the shop, I did not have something fully seated when I installed that bearing. That bearing's press fit, it's cooled down now, so I'm going to have to pull out the input and the output shafts and see what I can do in order to get that bearing further seated onto the shaft and eliminate this excessive in-play in the second gear, and that should allow me to get my stack up for the correct in-play up at the input shaft. Yesterday when we assembled this first and second gear assembly back at the school, I apparently did not have something fully seated. My first gear has quite a bit of play here. Well, it just depends on which way I can move the whole 1-2 assembly. Has quite a bit of play, and the only thing it's retained by is that bearing. I installed that bearing hot so it dropped right into place, but something down below, probably in the synchronizer assembly, was not fully seated, holding up just a little bit and kept that bearing from fully seating. Now I've got to see if I can find a appropriate adapter or tube to come down around this bearing cage, press just on the inner bearing, and get that bearing seated in. We may be done for the day. We'll find out. Service manual does call for a special service tool to install this bearing where you get down and press it directly against that inner race. Working here in my home shop, I don't have that tool. I'd like to get this assembled before next week when I potentially have access to the school shop again. The first thing I thought about was to go to look at my ball joint press. Well, none of the ball joint press adapters was going to work, but in my axle service stuff, I have a variety of old axle nuts. This is an axle nut off of an older Ford 4-wheel drive, and that axle nut is hardened steel, and that comes down and puts all the pressure on that inner race. Now this definitely qualifies as a don't try this at home, but then I have my inner tie rod socket, and that's a long enough tube to get down completely over the output shaft and apply pressure to that axle nut. And so I'm going to get this down on the ground, give a little bit of persuasion, and see if we can get that bearing to fully seat so we can get this transmission properly assembled. And I've got the main gear assembly down on the ground with my axle nut, my improvised bearing installer. Let's give that a little persuasion, see if it wants to seat. Yeah, I can feel it move, and I definitely felt and hear the tone change when it drove home. And now I suspect we're no longer going to have that excessive end play in my gear assemblies. The end play on this transmission is controlled by these two selective shims that are mounted underneath the front bearing retainer against the bearing races. In order to find out if we've got the transmission properly assembled and if we have the proper shims, we've got to make 4 measurements with our depth micrometer. We have to measure the depth of this pocket, the depth of this pocket, and then we also have to make some measurements on the bearings themselves. The measurements on the transmission bearings are going to be right here against this input shaft race and here against the counter shaft race. When properly assembled, the input shaft race does set up above the transmission case slightly, and the counter shaft race sets below the transmission case. For that reason, after we make our 4 measurements, we're going to have to subtract the 2 measurements on the input shaft, but we're going to have to add the 2 measurements on the output shaft. What we're trying to establish is what's the total distance that needs to be taken up by the shim. So first we're going to come in with our depth micrometer. I would rather use a metric micrometer, but I have a standard one available to me. So with my depth micrometer, I'll come in and make a measurement of my race, and I need to make that measurement in 2 or 3 places, an average, and that measurement on my input shaft is coming up with an average of 123 thousandths. This race is setting about 123 thousandths above the surface of the case. Then I do that same thing here with my counter shaft, but again the counter shaft is setting down below the case instead of above, but again I'll measure that in a couple of places, and my counter shaft average comes out to 43 thousandths. So my counter shaft sets 43 thousandths below the case, and my input shaft sets 123 thousandths above the case. And now we're going to make those same measurements on the pockets machined into the input shaft bearing retainer. And I've made these measurements in several spots already. They're coming out exactly the same all the way around. And I come out right at 260 thousandths on my input shaft. The pocket on my counter shaft is not near as deep. And I come out on my counter shaft, I'm coming out to about 82 thousandths. Now with those measurements, on the input shaft side we subtract 260 thousandths minus 123 thousandths equals 137 thousandths. And then on the counter shaft side we have to add. So 82 thousandths plus 43 thousandths, well that gives us 125 thousandths. Well that's nice. What do we do with those numbers? Well we have to take those numbers to the service information. And in the service information they give us some charts that tell us what thickness these shims should be. Once we have those 4 numbers, then we need to measure our shims and compare them to the chart and see if we have the appropriate shim. With a 137 thousandths total measurement on my input shaft, the chart says I should have a 133 thousandths shim. And with my slide caliper there, I measure 134 thousandths. On the output shaft side, on the counter shaft side, with 125 thousandths measurement, the chart says we should have a 118 thousandths shim. And I measured about 117 thousandths with my slide caliper. So it does appear that we have the appropriate shim selected for the transmission. Now we're ready to assemble that input shaft bearing retainer, and we'll have 1st through 4th gears assembled on this transmission. And now we've got the main part of the gearbox reassembled. We still have 5th and reverse to go, and of course the shifter assembly. But at this point it's a good opportunity to take advantage, make sure everything does seem to be assembled so far. I can turn the input shaft without the output shaft turning. So I've got neutral. I can slide this synchronizer ring back and engage 1st gear. I can slide this synchronizer ring forward and engage 2nd gear. I can engage this synchronizer sleeve rearward and engage 3rd gear, and that synchronizer ring forward and engage 4th gear. And I'm also turning all that by hand now. So this transmission was very stiff when I took it apart before. I never found anything that I really can guarantee was misassembled. Something just was in a bit of a bind, and it certainly turns much easier now. And you can see it's easier to turn the input shaft without turning the output shaft. So one of the synchronizers was apparently in a bit of a bind the way it was assembled the first time. But we've got 1st through 4th assembled, and we're making progress on this transmission.